Let's go ahead and take a look at this coordinate plane open-ended question together. Now, as we go through the different parts of this problem, we want to make sure that we're using sound reasoning, logic, and some systematic work so it's very clear and organized so that we can go ahead and justify each of the responses or the answers that we are giving. Alright, so what's the situation here? It looks like Mr. Lee wants to learn how to swim, so he's going to go ahead and build a rectangular swimming pool in the backyard. Okay, so he's going to go ahead and sketch a blueprint on a coordinate plane so he can kind of see the blueprints of this swimming pool. Now for the four corners of this swimming pool, looks like we have corner 1, corner 2, corner 3, and corner 4. So what do we have to do here? Looks like we're going to start by creating an accurate sketch of this rectangular swimming pool on the coordinate plane below. And then we have to do some explaining. So let's go ahead and just do the sketching part first and then come back to that next part. So let's start with corner 1. So for corner 1, that's going to be point M. So plotting this point, it's going to start at the origin, then move 3 units to the right. And then we're going to move 4.5 units down, which I think is going to be right about here. All right, so let's go ahead and plot that point down. 3, negative 4.5. I'm going to plot that and write the letter M. All right, so what about corner number 2? For corner number 2, that's going to be 3, 7.5. So start at the origin here, move to 3 to the right for positive 3, then up 7.5. So 7.5, here's 6, and then here's 7, here's like 0.5 right about here. So it's going to be over here in quadrant 1, so it's going to be point A. Moving on to corner 3, this is going to be T. That's going to be negative 6.5, 7.5, so starting at the origin, 6.5 in this direction to the left, and then we're going to move up 7.5, so we're 7.5. That looks like it's going to be right around here, okay, right in the middle of this square, or this grid box here, so right about here to me looks like this is going to be point T. Finally for H we have negative 6.5, negative 4.5, so we're going to move 6.5 units over in the left direction here, and then we're going to go 4.5 units down. So 4.5 units down looks like it's right about here, just a little higher than there, so 6.5 to the left, 4.5 down, I think is going to be right here. So this right here, I'm going to go ahead and call that point H. Alright, so connecting these points here, it looks like we have a rectangle like this. So it looks like we took care of that sketch of this swimming pool, and now let's see what we have to do next. I think the next thing to do here is, it says that we have to go ahead and explain something. We're going to go and explain how you can tell that the sketch of the swimming pool will make a rectangle by just looking at the points or the coordinates and not looking at the actual graph. Now one thing we can say, that we know the coordinates will form a rectangle because point M and point A have the same x coordinate, point A and point T have the same y coordinate, point T and point H have the same x coordinate, and point H and point M have the same y coordinate. In addition, we can go ahead and say that the length of segment MA is equal to the length of segment TH, and that the length of segment TA is the same length as segment MH. Hopefully that makes sense because rectangles have 4 lines and 2 of them are always going to be the same length and the other 2 are also going to be the same length. Alright, let's move on to part B. For part B, let's go ahead and see if we can find out the perimeter of this swimming pool, and then we're going to find out what this is measured in units first, right? So what is the perimeter formula? Well, the perimeter formula is going to be P equals, or perimeter equals, 2 times whatever the length is, plus 2 times whatever the width is, right? So let's go ahead and take a look. For our sake, let's go ahead and call this side the length, and let's call this side the width. Okay, it doesn't really matter which is which as long as you know which one you're talking about. So the length here is going to be from M to H, right? So from M to H, let's go ahead and see if we can figure out what the length is going to be. So the length is going to be the distance from M to H. So looking at M and H together, let's see, M is this point here and H is this point here. We can notice that they have matching y values or y coordinates of negative 4.5 and negative 4.5. So to find the distance between these 2 points, we can just take a look at their x values. You have 3 and negative 6.5. So if they're in different quadrants, we're going to go ahead and add their absolute values, and that'll be the distance between these 2 points, between M and H. So let's go ahead and say we have the absolute value of 3 plus the absolute value of that negative 6.5 Now the absolute value of 3 is just going to be 3. So we can say the length here is going to be 3 plus 6.5 because that's the absolute value of 6.5. So the length here is going to be 9.5 units, or I'm just going to go ahead and write U for now. All right. Now what about the width? The width here looks like on our picture is going to be from A all the way to M. So let's go ahead and see what are the coordinates here. So we have A over here of 3, 7.5, and we have M of 3, negative 4.5. They have matching x coordinates, which makes sense. They're vertical of each other. And so we just have to find the distance between negative 4.5 and 7.5. And these are also in different quadrants, so we're going to add their absolute values. So looks like we're going to add the absolute value of negative 4.5 with the absolute value of 7.5 or negative 7.5. So let's see, absolute value of negative 4.5 plus the absolute value of negative 7.5. Now the absolute value of negative 4.5 is just going to be 4.5. And then the absolute value of negative 7.5 is 7.5. So 4.5 plus 7.5, that should be equal to 12 units. All right, now that we know that the length is equal to 9.5 units and the width is equal to 12 units, let's go ahead and substitute those in for L and W here. So the perimeter is going to be equal to 2 times this 9.5 units plus 2 times this 12 units over here. Okay, now if we go ahead and figure this out, 2 times 9.5, that's going to be 19 units. So I'm going to write 19 plus, and then 2 times 12 is going to be 24. So if we had 19 plus 24, I believe the perimeter of this swimming pool, at least in the drawing, is going to be, let's see, 20, that's 44, 43. I think this is going to be 43 units. And so just looking at the drawing, the perimeter is going to be 43 units on this sketch. Then we're being asked to find the perimeter of the actual swimming pool if each of these units that are on this coordinate plane is actually representing 4.5 meters in real life. So if one unit is going to represent 4.5 meters, then 2 units would represent double that, 3 units would be triple that. So what if we have 43 of these units? Well, to figure this out, we'll take each of these 43 units and then multiply that by 4.5. And if we go ahead and multiply 43 times 4.5, that's going to be 193.5. And this is going to be not units now, though. This is going to be meters. So I'm going to put meters next to this. And so while I didn't show the multiplication for some of these decimals, like I didn't multiply 2 times 9.5 out, you can totally take some scratch paper and do that on the side. Also, I didn't show the multiplication for these decimals, but you should go ahead and do that. Make sure you feel comfortable to get this 193.5 meters. That would be the perimeter of the swimming pool in real life. All right, next let's look at part C. We're going to go ahead and determine the actual area of the swimming pool. And we know this is actual area, not just the sketch, because it says in square meters. Now, after all, this is a rectangle. So to find the area of a rectangle, this is just going to be length multiplied by width, right? Now, in our case here, we can go ahead and figure out the area pretty easily with the measurements in units, but we need to go ahead and make sure we can figure out what these are in meters, right? So let's go ahead and remember what our measurements were. So we said that the length was 9.5 of these units. And we said the width earlier was going to be that 12 units, right? That's just going to be in units though. Now, if we want to go ahead and turn these into meters, we have to take this 9.5, and remember each of those 9.5 units is representing 4.5 of these meters. So we're going to go ahead and multiply 9.5 by this 4.5. So 9.5 times 4.5, again, you can, if you need to go ahead and write that out, feel free to do so. It's going to take a little bit of calculations on the side, but you need to use your standard algorithm for multiplication. And this is going to be 42.75 meters, right? So no longer being units, but in meters now, okay, in real life. And then what about the width? Well, the width also has to multiply by 4.5. All right, in the other dimension. So 12 multiplied by 4.5. Again, I'm not showing that right now, but this is going to be 54 meters. All right, so we now know the length and we now know the width in meters. So here's the length and here's the width. Let's go ahead and substitute that in. So the area is going to be a length of 42.75 meters. And then we're going to go ahead and multiply that by 54 meters. Okay, so again, these are just the length and width dimensions of this real life rectangle instead. Now, if you need to pause and go ahead and multiply these two decimals out, go ahead and practice doing that to make sure you feel comfortable multiplying these decimals. Now, if we do that, I believe we should get that the area of this swimming pool in square meters is going to be 2,308 and 5/10, or 0.5 square meters. And so if we want to find the area, we needed to multiply the length and width together. If we just multiplied this 9.5 and 12, that would get the area, but that would be in just square units. If you wanted to do that in the square meters, we had to go ahead and multiply each of these measurements by 4.5 to get what it was in meters. So we go ahead and multiply each of these by 4.5. Once we found out the new length and width in meters, if you go ahead and multiply those two dimensions, you end up with our area in square meters. So there you have this open-ended question dealing with the coordinate plane, where we also had to use some absolute values to make sure we could find the distance between some of these coordinates as well. And we also had to apply our understanding of knowing that we could multiply decimals well, so that we could get these new dimensions and do this in a different type of unit. So hopefully you found the video helpful. If you did, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.